Well, this is I like to think about things that are complex. What happens when they break down? And when they break down, it sort of helps us figure out how they're supposed to work. So for instance, if your starter was missing in your car, you'd notice that you wouldn't start your car anymore, so you know that it's crucial for starting up the car. And then if you took it after the car was started, you'd notice that it only worked during that one time and that's it. So that's why I like to look at things when they're sort of broken down, because that helps me figure out what they're really supposed to do. So let's talk about poisons and how poisons affect this specific area. So the first thing is that there are different poisons that basically all work on this one pathway. And they basically cause you to die different ways. And like for instance, we all respect carbon monoxide and cyanide. We know that those are two strong poisons, and what happens with them is that they start to come to this one area that's in charge of getting those electrons. Remember how NADH and FADH have these electrons that come this direction? And their job is to bind the hydrogens and the oxygens to become water, and that water leaves. Well, if you stop that one system, everybody knows that if you have carbon monoxide poisoning or cyanide, you die. And the reason being is that you have this high concentration of hydrogens on this one side and this low concentration on the other. And eventually what happens is they both get to equilibrium. So when they both get to equilibrium, then what happens is the cell sort of shuts down and stops. And anybody that had carbon monoxide poisoning or died of it, they usually say that what happens is they start to get sleepy, and then eventually they start to completely fall asleep and die. And the reason being is because you're kind of like a cell phone that's starting to die out. You had all this energy, and now all of a sudden you can't make any more energy, so you're starting to slow down. And what happens is when you're starting to really power down, your body tries to figure out, where should I send energy? Like, what are the most crucial places that need energy? And that's going to be your brain and your heart. Your muscles and everything like that, they had their chance. They couldn't figure out that they were in carbon monoxide. So they're taking energy from there and starting to move it to those two organs until eventually you run out of oxygen and die. Let's do rotenone next. Rotenone basically is this molecule that blocks this enzyme. And by blocking this enzyme, it causes it so these hydrogen ions can no longer go this direction, and these electrons can't continue this direction. So because that happens, we end up having a situation where you start to shut everything down. So for instance, if these hydrogen ions can't come up here, we end up not having that hydrogen gradient that we need. Because FADH will still work, but remember how with one glucose molecule we only make 2, and with one glucose molecule we make 10 NADHs? So we're going to get a lot more hydrogen and electron ions from NADH. So if you shut this particular pathway down, these electrons can't continue, and if they can't continue, these hydrogens and oxygens can't come together to be wastewater and leave. So what ends up happening is, and rotenone is in flea medication. It's the compound that's in flea medication. What ends up happening is that, again, you start to power down and die. We invented this because we want to put this in fleas and cause them to die, because they have the same exact pathway. And by blocking this pathway in fleas and ticks, it causes them to die. But what was happening is, because it came in a powdered form and you had to put it in water to sort of wash your dog or cat, kids were getting it into their lungs, and they were getting a larger amount, and that was causing their cells to sort of die. If a human, like an adult, got some in, the dosage would be so small that we'd really feel run down and sick for a while, but we'd recover. But kids are so small, they don't have as many cells, they don't have as many abilities to recover than we do, so they end up dying. Our next poison is going to be from mushrooms. And if you remember with mushrooms, you're not supposed to eat mushrooms that you find in the street. So those mushrooms are poisonous, and what happens with those mushrooms is this poison will come and block ATP synthase. And by blocking ATP synthase, we're going to make it so all those high hydrogen ions aren't going to be able to come down the ATP synthase, and it's stopped. So what's going to stop is this process of making ATP. And when you stop making the ATP, what ends up happening is you start to power down and die. That's why eating those random mushrooms that you find in the street or wherever are not the greatest idea, because of this toxin. Some people use these mushrooms, they're called magic mushrooms, and they feel really good afterwards, and they have this sort of toxin euphoric high. Some of it's because this amount is really low, and it sort of gives them that high. And another thing is that it produces a toxin. And that toxin sort of makes the brain sort of blurry for a while, and it doesn't work really well. And that blurriness is what they're actually getting off on. Our last poison, which is going to be DNP, is basically what it was designed to do was to make this hydrogen gradient, it makes this hydrogen gradient leaky. So remember these lipid bilayers? What happens is they get really leaky and loose. And because of that, we can't have that high concentration to low. All these hydrogen ions, some of them are coming this direction, but most of them are coming through this direction. And because of that, what happens is it makes you a lot less efficient. And when you're less efficient, you start to burn fat. So this was one of those products that were used to help you lose weight. Fen-phen, things like that. And what happened is it made it so these hydrogens leaked and didn't make you as much ATP. So instead of making 36 to 38 ATP like we should be doing from one glucose molecule, maybe you'd only make 10 or 12. And it was because some of it was going to go through the ATP synthase, but not a lot. And that would cause you to become so much more inefficient. The only way that you could keep yourself going is to go to reserve fat storages and burn them off. And that was sort of the intended result. Sadly, when there's anything out there that's has this kind of effect, people abuse it. And people took way too much concentration of that fen-phen, and it caused them to not make any energy. And when you don't make any energy, we basically call you dead. So that's the poisons, and I hope by going over them, they basically told you how it makes us so efficient, how the real things work. So you can clearly see when, like, this isn't working, this enzyme, no hydrogen gradient will occur. When this enzyme isn't working also, we won't be able to get that electrons to go through to make water. And that will shut the system down. If we use something like fen-phen to make this area leakier, we're going to, of course, make ATP synthase work less. And with less ATP synthase, that means less ATP. And when you have less ATP, you start to power down and die. Carbon monoxide, we talked about that, basically the oxygen not coming into your body. And now what's happening is that you can't complete this reaction. And when you can't complete this reaction, again, you die. Okay, our next video will cover this sort of as a recap.